Good morning. It's certainly a pleasure to provide to you the industry perspective, as well as another important sponsor of the project that I'm managing. My day job is the Site Chief Geotechnical Engineer at Savannah Riverside, but I'm here today as the project manager for the seismic source characterization model development for the Central and East United States. In 2008, I was able to establish a partnership between industry and government that eventually provided the funding for this important project. As you may or may not know, when you're asked to perform a probabilistic seismic hazard assessment, two major inputs is the seismic source characterization model as well as the attenuation models that are also used. So the focus in the last 3 years have been to develop the source model, and the work that you will hear today with the Sigma beginning one of the first relevant parts of the next generation program. The message that I gave, I think, is important for many of the professionals and for those funding agencies out there. This was given to the potential sponsors in 2008. It applies today, and we've been living this for the last 3 years. And that message is, you can do more for less with reduced risk through standardization and partnering. Each sponsor will provide results important to their mission at no more than half the cost if they had done it themselves. Reduced risk because full engagement is really the motto of the project, which means we have drawn all stakeholders into the project team in some capacity to essentially participate, which means in the end we are capturing the center body range of this team as well as the resource experts, which number approximately 50 in the course of our project, included in the results. Industry had a need, and essentially it can be summed up by stability. If you are a CEO of a utility and you're about to invest billions of dollars in a nuclear reactor, you need to be confident that the seismic design basis will not change during the course of the design or the licensing of this facility. Likewise, the reviewer, Nuclear Regulatory Commission, they had an approach to be able to review effectively the applications that they received. It was called the design-centered approach, which means that once a project has been reviewed in the capacity, so the input to an application has already been vetted, then they don't need to review it in a subsequent application, which expedites their review. The other question important to industry was the need for updates. How do we know when we need to update the work that we will do on the source model and what will be done on the next generation project? So we are looking very closely in those factors that affect the hazard. We have done a considerable amount of sensitivity analysis to understand those factors that affect the bottom line, which is seismic hazard. And we've looked at what is the precision of the seismic hazard answer so that we have an idea that if the hazard curve, which is annual probability of exceedance versus ground motion, if that changes, then we have some idea of what is kind of the noise within the ability to compute seismic hazard. Now, for the Department of Energy, their need was each of the sites in the central and east United States within the DOE complex was about to perform a 10-year update as part of DOE Order 420.1. As part of the DOE Nuclear Program 2010 to facilitate nuclear power plants, this also created a need for this project. So their need is addressed in that this will provide cost and schedule savings as part of those updates for those sites in the DOE complex. Each of the sponsors, EPRI, NRC, and DOE, can agree on one need, and that is transparency. So that everything that we are doing, whether you have walked the road with us during the course of the 3-year project, will be transparent. So you will know the background for what you see, and you will have the information to run the models yourself on a public website. Let's talk about the products briefly, and then we'll quickly go through over some of the details. In the limited time, I can't go into quite a detail. I want the focus to be really on the NGA East project and the Sigma workshop. But to give you an idea, there's more than just the model that will come out of this project. The first is an earthquake catalog with all the magnitudes converted to moment magnitude. This is extremely important because the ground motion models of today use moment magnitude. So there's been a considerable amount of effort and cooperation, and I should also mention the USGS, who is fully engaged with our team and as an expert agency who is on a 5-year basis evaluating the state of practice to create national seismic hazard maps. Their insights and perspective has been extremely valuable. So that earthquake catalog will be shared with the NGA East team to help in the overall process of getting to the new models. Likewise, paleoliquefaction database will be assembled of all the study areas that have been recorded and published to date. For those not familiar with paleoliquefaction, it is essentially a record in the soils that can do the prehistoric earthquakes. So we have some sense of the recurrence and the magnitude of previous earthquakes, and the locations help us define the extent of where some of the sources have occurred. Likewise, we're taking a look at new smoothing techniques. This is how we smooth the empirical data of the earthquakes that have occurred within the central United States. And again, we will have a clear understanding of those sources that affect hazard. Why is that important? To the technical integration team of our project, that's important because they want to focus on those characteristics that are important to the final seismic hazard and not spend the valuable time on maybe those source characteristics that don't affect hazard. Likewise, for the industry, having those characteristics that are important identified also helps in future stability with respect to the model, so that you know whether new information will truly affect the answer that is being generated by this work. So with that introduction and orientation with respect to this perspective, we'll quickly go through some of the things so you see a little about our project. And I would also encourage you to visit EPRI.com, the Advanced Nuclear Technology Action Plan Committee, which is represented by about 30 utilities and vendors, are sponsoring it on the industry side. And that website will produce the project plan for this project, as well as workshops results for your downloading so that you can see some of the details. The goals, the EPRI 1989, the Livermore 1993 hazard models had served us well, but it was time for an update and an opportunity to assemble the advancements in the science. Providing an up-to-date, consistent, stable basis for a site-specific PSHA for locations in the central United States was important. So this is an important goal. The third is essentially the SHAC goal of capturing the knowledge and uncertainties of the informed scientific community using a SHAC Level 3 process. And again, I think where this SHAC 3 process has been applied, I think we're unique in terms of the world and having all stakeholders participate as part of this process. So we have a very excellent, skilled, experienced team working together to solve the basic problem of generating a new source model. And then ultimately it would be vetted, and it'll also be showcased to the oversight group for the Department of Energy, Defense Nuclear Facility Safety Board, the Nuclear Regulatory Commission, industry in terms of the Structural and Reliability Committee, and the Department of Energy. Here's a quick look of our study area. As you can see, it's essentially east of the Rockies. We have used the NRC guidance of 320 kilometers where we can, as well as looking for the boundary of stable continental crust, so that we have drawn the study area that you see today. The 7 sites are areas that we call test sites, and I'll explain quickly later what we do with the test sites. Here's our progress to date. You see the completion of the project plan. 3 workshops consistent with the SHAC guidelines. SHAC workshop number 1 is database compilation. Here we identify any data gaps that we may have in our database. 2 is where the proponents come together and talk about various interpretations with respect to the source models. And the 3rd is the feedback, where we're able to look using a sensitivity model at those factors that affect hazard. From April 2010 to July 2010, we will essentially construct the final model and prepare the draft report for review. The final report will be developed December 31st, 2010. We're already working on the design of the website, and we'll be populating that shortly after the information is available from the project. The technical developments, just quickly I want to mention what we're seeing in the source model. We're looking at repeated large magnitude earthquake areas that have been identified from our tectonic framework, and also areas of high seismicity. Again, one of the things we wanted to do with respect to the model is not have issues about the model come out later. We wanted, before the model was published, to test it. So we will test the model. Our goal was not to compute hazard at various locations and to have a grid of total hazard, but we picked these test sites because they represent different hazard environments, and we were able to compute the total hazard at rock on a generic soil, shallow soil profile, and then a deep soil profile. And this will give us some idea with respect to how the model is performing. Also, we want to be able to check at rock the comparison of the model with the USGS model that is available and the model that is representative of the EPRI update that is part of the applications for the current licenses. And this will, again, give us an indication of the performance of the new model. My conversations with the USGS has been very cooperative and collaborative, and that we both, our group and the USGS, also will benefit from this comparison, because ultimately what we're asking is that there be a foundation for future work that can be utilized, not necessarily that any one agency will use this model in exact form, but that the foundation and the tools used can be adapted as time goes on with respect to those who are essentially developing seismic hazard maps. The next critical steps are the sensitivity model has been completed, and the factors that have essentially affect seismic hazard are now known by the team, and they're assembling that work for the development of the preliminary seismic model, seismic hazard model, seismic source characterization model on February 26th. The funding for the public website has been obtained, and we will be beginning the development and design of the website. The final model will be available April 30th, and then we work towards the sensitivity analysis that I just described, the assessment in May and June of this year, with the results being available to the project team on July 1st. And then the month of August will be used for the reviewers, the sponsor reviewers, and other reviewers, the participatory peer review panel that we have to review the draft report. With that said, I'll close, and I'll also make a note that if we can expedite the time it takes for the probabilistic seismic hazard assessment to be done in terms of preparation for applications or reviews, this is the key towards our goal of U.S. energy independence. Thank you for your attention.
Great.